So what we are going to do now is we are going to learn about prisms. Okay, so we will be learning about the refraction through prisms and so on. What we have understood so far is we have understood something called as total internal reflection. We have understood the basic concept of refraction. Okay, what we want to do is we want to specifically understand triangular prism. So this is a triangular prism. So if this is a triangular prism, this angle here is A, called the angle of the prism. This is B, this is C, also called the refracting angle. Suppose this is made up of a material of refractive index mu. Suppose there is a light ray which is incident this way. It is moving from rarer to denser medium, so it bends towards the normal. Now again it is moving from denser to rarer medium, the normal is on this side, so it is bending away from normal. So typically a ray which is incident on the mirror, on the prism, goes this way. Okay, it bends away from normal the first time towards the normal, second time it bends away from the normal. This angle A is called the refracting angle. This is the angle of incidence. This is called R1, the angle of emergence, angle of refraction 1. This is R2, the angle of refraction again. This is E, the angle of emergence. So I'll just draw a slightly bigger diagram so that we'll understand what is happening. So a ray of light goes this way, this is the normal, it goes this way, this is again the normal, and then again it goes this way. Okay, so this is how a ray of light travels. So this is A here, this is B here, and this is C. So what happens is, suppose this ray goes in this direction, this ray again tends to go in this direction, and this angle here is called the deviation. So this angle here is called the deviation. The ray was supposed to go this way, but it landed up going this way, so it got deviated from its path. So that is called the deviation. So these are the two normals. The normals meet at this point. So let's put some names. This is I have already mentioned. This is R1, I have already mentioned. This is R2, I have already mentioned. So let me call this B. Let me call this C. And then let's call this B, let's call this cyclically B, C, D, E. Okay. Now from these angles, it's very easy for you to say that this angle here, angle B, is 180 degrees minus R1 plus R2. Basically this is a triangle, so in this triangle this is R1, this is R2, so this will be 180 minus R1 plus R2. Similarly, this is opposite to this, so this angle, this full thing here is I, this is E, this full thing here is E, because they are opposite angles. Now this angle is 180 minus deviation, this angle here is 180 minus R1 plus R2. So now we can try to bring out a relationship between them, but before that, this angle here is 90 because it's a normal, this angle here is 90 because it's a normal. So this and this will also be add up to 180. So from there I can say that if this angle is A, this is also equal to 180 minus A. In other words, angle A, the refracting angle of the prism, is equal to R1 plus R2. Yes. Then if we look at that quadrilateral, I have I plus E plus 180 minus deviation plus 180 minus A is equal to 360 degrees. So you can cancel these two, and then from there you can get another equation, I plus E is equal to A plus deviation. So you have two fundamental equations which we will work with. So I will explain this again. Suppose you have a triangle this way. Suppose we will call this A, the angle of the prism. Suppose a ray of light is going this way, it hits, it goes this way, it hits again, it then goes out like this. Suppose these two meet at this particular point. So this is the normal. So this is the normal here, this is the normal here. So this angle here is equal to 180 minus A. because this is a quadrilateral, total 360. These two angles total up to 180, so this must be totaling up to 180. So this is 180 minus A. If you consider this as R1, if you consider this as R2, then I can say that 180 minus R1 plus R2 is also equal to this. So from there I can say that A is equal to R1 plus R2. Okay. Now similarly, suppose I just extend this, because I am extending this, this is equal to, if this is I, this is also I, if this is E, this is also E, then this angle here is deviation. So here you have 180 minus deviation. So from there I can say that I plus E is equal to A plus deviation. Okay, I already explained that in the previous case. If you want it to be specific, this is I plus this angle here is E plus 180 minus A plus 180 minus deviation is equal to 360. So if you have this, these two get cancelled with this. So you get I plus E is equal to A plus deviation. Okay, so this is how we will get. So one equation we have, A is equal to R1 plus R2. Another equation you have is I plus E is equal to A plus deviation. So with these two equations we will work, and then we will try to see how we can move ahead. Okay, now before we move on, there is a small experiment that you have done, or experimentally it is observed that if you change the angle of incidence, if you increase the angle of incidence, the angle of deviation first decreases and then again tends to increase. This is the angle of deviation. Experimentally it has been observed that as you increase the angle of incidence, the angle of deviation first decreases and then increases. Suppose I have this angle here and I have this angle here. This angle is called the angle of minimum deviation, D minimum. This is I, the angle corresponding to the angle of minimum deviation, the value corresponding, angle of incidence corresponding to the angle of minimum deviation. Now if you have a prism like this, and if this is the angle of minimum deviation, or this is the angle of incidence corresponding to minimum deviation, then this ray is parallel to this ray. Do we get it? This ray is parallel to this ray, and if this ray is parallel to this ray, also we will see that I will be equal to E. If this is I will be equal to E. This is what happens at minimum deviation. If I is equal to E, R1 is equal to R2. That means this angle here, R1 becomes equal to R2. If you are worried about why R1 should be equal to R2, is I have that sin I by sin R is equal to mu. Sin I by sin R is equal to mu. So from here I am able to say that R1 is equal to R2. So if R1 is equal to R2 and sin I by sin R is equal to mu, then I can now go back and say that look, I have R1 plus R2 is equal to A. So R1 is equal to A by 2, because R1 is equal to R2. Similarly, I plus E is equal to A plus deviation. So from there I can say I is equal to A plus deviation by 2. So from there I can say that mu is equal to sine of I, that is A plus deviation by 2 divided by sine of A by 2. This is mu is equal to sine A plus deviation by 2 divided by sine A by 2. Now this is an equation that we have derived from this. This deviation corresponds to the angle of minimum deviation. A corresponds to the refracting angle of the prism. Usually we will be working with 90, 30, 60 triangles, or we can be working with isosceles triangles, that is 90, 45, 45, or equilateral prisms. Okay. Now if you are working with an equilateral prism, then we can say that sine A, that is 60 plus D minimum by 2 divided by sine of A by 2, A is 60 by 2 is equal to mu. Okay. Now we know mu is equal to 3 by 2. Suppose we have glass, mu will become equal to 3 by 2. Sine 60 by 2 is sine 30. Sine 30 is half. So the 2 comes here. So I will have 60 plus D minimum by 2 sine of will become equal to 3 by 4. Okay, now I can look at the tables and find out what is the value for sine inverse of 3 by 4. So from there I can say that 60 plus d minimum is equal to 2 times sine inverse of 3 by 4, and from there I can say that d minimum is equal to sine inverse of the sine inverse of 3 by 4 for your information will be something like 51-52 degrees centigrade degrees. If it is 52 degrees or 51 degrees, suppose it is approximately 1 or 2, so d minimum will become 2 into 51 minus 60, so that is approximately 1 or 2 minus 60, that will be some 42 degrees. Okay, so this is the minimum angle of a minimum deviation as far as a prism is concerned. Okay, so I hope you are able to understand this.